In this problem, we want to calculate the average rate of change, and notice that we're given a formula, but we also have that formula or that function given to us as a graph. So we can actually use the graph to estimate our points, and then once we have our points, so you always want to make sure that you get your 2 points. So you can think of those points as x sub 1 comma y sub 1 and x sub 2 comma y sub 2, and then once you have those points to calculate the average rate of change over the interval x sub 1 to x sub 2, we would simply have to find the output value. So I would need to figure out what the corresponding y value is that goes with that x sub 2 value, and then I'd have to figure out what the corresponding y value is for that x sub 1 point. Okay, so if we take a look at the formula, so I'll just use the formula here, right? When I know that t is, so let's just find the average rate of change over the interval -1 to 1, and then we'll do the last one, 3 to 5. So let's do the first one first, -1 to 1. So this means I need to calculate the average rate of change when t is -1. So from -1, all right, or excuse me, -1 to +1. And then when t is +1. And if we look at the graph, we can kind of estimate that at -1, it looks like that y value is also -1. And when x is +1, it looks like that y value is 2. But let's use a formula just to make sure that we actually get those output values. Okay, so I need to figure out what the y value is by calculating h of t. So just remember that h of t is the same thing as y. So to do this, we're going to substitute in -1 in for t. So wherever we see t in that equation for h of t, we're going to substitute in -1. Okay, so if you put this into your calculator, that's going to give you -1. So it does confirm that this is -1. Okay, all right, let's do the same thing for when t is 1. So h of 1, put it back into the equation, and that is going to give us an output of 2. So now that I have my output values, write them as an ordered pair. So I always tell students that sometimes it's helpful to write out your points as an ordered pair so that you can use the formula to calculate the average rate of change more easily. So then now we can clearly see what our x sub 1, y sub 1 values are and what our x sub 2, y sub 2 values are. So let's go ahead and just put it into the formula. So to calculate the average rate of change, we just need to substitute in our values. So let's calculate the average rate of change over the interval from -1 to 1. So our x values, that'll be 1 minus -1, and our y values, that's 2 minus -1, which gives us 3 over 2, or you can convert that to a decimal, that's 1.5. So our average rate of change over that interval is 1.5. Now let's calculate the average rate of change. So we're going to do the same thing again, but this time let's calculate the average rate of change over the interval from 3 to 5. So if we take a look at the graph, when x is 3, we go up to the graph, we can see that the corresponding y value looks like it's approximately 2.75. And then when x is 5, let's go up to the graph. It looks like it's getting really close to 3, close to 3. But to find out for sure, we're going to have to substitute it into the equation. So I'll just continue with the blue pen here. So let's evaluate when x, or you can think of that as t, x or t, x sub 1 or t sub 1. When that's 3, let's figure out what h of 3 is, and then let's figure out what h of 5 is. Okay, so it's just substituting that value, t equals 3 into the equation, and t equals 5 into the equation. Okay, all right, so go ahead and take out your calculator. When you put that into your calculator, you should get something close to 2.75, so that does confirm what we see visually in the graph. And then now if I substitute in when t is 5, okay, that gives me approximately if we round, 2.94. Okay, so now that I have my 2 points, I'm going to write it over here because I need a little bit more space. Again, write it out as an ordered pair if that helps you see your input and your output values. So when x is 5, y is 2.94. Again, you can use x's instead of t's, whatever notation you're comfortable with. And then x sub 2 and y sub 2. And then now let's substitute it into the formula to calculate the average rate of change over that interval from 3 to 5. Gives us, okay, let's do the x, so 5 minus 3 and that's 2.94 minus 2.75, okay? And that should give you 0.19 over 2, which simplifies to 0.095. So that's the average rate of change over that interval from 3 to 5. So one thing that I want you to notice is notice that the average rate of change over the interval -1 to 1 is much greater than the average rate of change over the interval from 3 to 5. And we can see that visually if we go to the graph. So I'm going to connect the point that connects the point at x equals -1 to x equals 1. And hopefully you can see that the slope of this line is relatively steep, whereas if I connect with a blue line here, the point at x equals 3 and x equals 5, I hope that you can see that the blue line, the slope is much steeper because the slope here of that line, right, has an average rate of change of only 0.095, whereas the slope between the first 2 points here, this guy here, has a slope of 1.5, which is much steeper. So this tells us that the function h of t, it is increasing over time, but it's increasing at a decreasing rate because as x or as t gets larger, we see that the rate or the average rate of change starts to slow down.